Hi, I'm Vincenzo Coya. Welcome to Stat 545, the video series designed to help you write a clean and modern data analysis. You can get pretty far when it comes to drawing insight from your data by making plots and doing data wrangling, like we've done so far in the course. But sometimes you just need to go a little bit further and fit models.
For example, we can learn how a car's weight influences mileage through this scatter plot. We can be pretty convinced that heavier cars tend to have lower mileage in general, and we can even make ballpark predictions. A car that weighs 3,000 pounds is expected to have a mileage of around 20 miles per gallon. We're able to be more precise by fitting a model. Based on this model, we can make a precise prediction of a car's mileage that weighs 3,000 pounds by simply evaluating the line. And we can even do a hypothesis test to check whether or not this downward slope is just an artifact of the data.
This course isn't about modeling. Instead, what we'll do in this episode is look into how to make a model object in R and how to work with that object. This does vary depending on the model you're working with, but in general, these models tend to adapt the same framework. The first step is to make your model object. To do this, you first need to find the function that will make the model object for you. And then once you do that, you typically need to do three things. You need to specify a formula, specify your data set, and then special options for that specific model.
For example, let's use a linear model like we saw earlier on the MT cars dataset, except this time, let's see how both the car's weight and the number of cylinders that a car has influences its mileage. To fit a linear model, we can use the LM function. Like most other modeling functions, LM first takes a formula. In this case, we want to see how the mileage, sometimes called the Y variable, is influenced by a car's weight and its number of cylinders, sometimes called the X variables. In general, one Y variable goes on the left-hand side of the tilde, and one or more X variables go on the right-hand side of the tilde, separated by plus signs. Lastly, we need to specify the dataset, and then if needed, more options specific to the model that you're using. In this case, we don't need any of these additional options. Running this LM function looks like it returns a bunch of text, but don't be fooled, this function actually outputs an object that's storing lots of information. Let's store the model object so that we can work with it later.
Remember, even if you're not using the LM function, your modeling function will probably use the same framework. The second step is to probe your model object using the Broom package. Now that you have your model object, there are typically three ways in which we can use that model object. And there are three functions in the Broom package that'll help us do just that.
First up is the tidy function. Use this for a statistical summary of each component of your model. In this case, there's one row per regression coefficient, which in this case are just the intercept and the slopes. Next is the augment function. You can use this function to make predictions on your dataset. The augment function by default makes predictions on the dataset that you used when you fit the model. Let's instead make predictions on three new cars. Cars that weigh 3, 4, and 5,000 pounds and have 4 cylinders. Lastly, use the glance function to extract a summary of the model as a whole. The glance function always returns a table with one row and model properties as columns.
The third step is to probe your model object in more traditional ways if the Broom package isn't working for you. So even though the Broom package does work for more of your common models, it doesn't work for every model. And the reason for this could be that sometimes a Broom function just doesn't make sense for a particular model, or maybe just somebody hasn't developed the Broom package to work for your model. If that's the case, here are three ways that you can go about working with that model object.
First, you can make predictions using the predict function. Like the augment function, the predict function by default predicts on the dataset that you used when fitting the model. The difference is that the predict function returns a vector of predictions, in this case a named vector, and not a tibble. Let's make predictions on the three new cars like we did with the augment function. cars that weigh 3, 4, and 5,000 pounds and have 4 cylinders. When it comes to an alternative for the Broom tidy and glance functions, check the modeling functions documentation to see if there are any other functions that you can use. For example, the COEF function gives you the regression coefficients as a vector, and the sigma function gives you an estimate of the standard deviation of the errors.
But don't be surprised if you still can't find what you're looking for. If that's the case, there's still one more thing you can do.
Your model object is probably just a list in disguise. And a light way to probe a list is to check out its names. Now I can directly extract, say, the degrees of freedom of the residuals. To complicate things further, even more information might be stored in yet another list after applying the summary function to the model object. Again, this looks like just a bunch of text, but don't be fooled, it's actually a list that's packed with even more information. As before, let's check out the names of this list, and then extract, say, the adjusted R².
Hopefully you're now empowered to work with models in R. Keep these steps in mind. First, make your model object, then probe your model object with the Broom package. Or if the Broom package isn't working for you, probe the model object in more traditional ways. I hope you enjoyed today's episode. As always, tune in next class where we discuss special data types in R. Don't forget to subscribe to this channel so that you can stay up to date with more data analysis goodies.